well, I guess maybe I ought to introduce myself. That's me. And my job at Amazon Web Services is to help people get a little bit more comfortable with the stuff that always makes people squirm, right? Anything related to security, privacy, compliance, data portability, location, that kind of stuff, right? The things that seem to be like secret sauce and magic. You know, yes, there's a lot of secret sauce. There's no magic that's going on. And so my job is to just communicate about that, right? Whether it's in a public forum like this, or one-on-one meetings with customers, or telephone calls, conference calls. You know, I'm more than happy to have any kind of follow-on conversations that you might want to have after you've seen the material here. If you've got an engineering group or security group who has lots of questions and you want to get on a conference call, please let me know. That's why I put all my contact information up there. This is my job, right, is to do this. And what I'd like to do in the time that we have together here is just kind of peel back the curtain a little bit and give you some insight into what we are doing in the infrastructure in AWS to help you understand how we protect your information, how we protect your compute instances, how we protect your data. And what I'd like you to do is, after you walk out of this room, is have a greater understanding for how serious we take this. Because if it weren't our top priority, then as a business, AWS would fail. I mean, think about what we're asking you to do is take the thing that you've been used to putting your arms around and give it to us, right? You need to have some mechanism by which you can trust that we're doing the right thing. And that's what I want to talk about, is the right things that we're doing. And sprinkled throughout, I'll have a little bit of guidance on some things that I think that you should be doing as well. Because I'm going to hit this notion of shared responsibility in a little bit. When you think about security and you think about the elements involved, you know, it's generally confidentiality, integrity, availability. I'm going to start with availability. So we have 4 geographic regions: California, Virginia, Ireland, Singapore, where we have compute and storage resources. We also have a content distribution network called CloudFront. So if you hook a CloudFront distribution to objects that are in an S3 storage bucket, then that will get pulled to whatever location is closest to the person who retrieved that. That helps you just lower your bandwidth utilization for static content that's stored in S3. So within each geographic region, we build what we call availability zones. You can roughly think of this as a data center. And there's at least 2 availability zones in each region. This is what helps achieve that high availability that you're accustomed to. In Virginia, there are actually 4 availability zones, just because that's where we began. And you do the typical things, right? You know, redundant power, backups, fire suppression, maybe some things you might not immediately think of when you try to build at the scale that Amazon Web Services builds at. And we've got to think about what would the planet do, right? So when we can, we try to isolate things so that movement of the earth or movement of water isn't going to wipe out an entire region. It's easy in some place like Virginia, right? A little bit more difficult in a 40 square mile island like Singapore to get high geographic isolation, but you know, we do what we can. It's important things to think about as you try to maximize availability. If you were to try to find where one of our availability zones is, you would fail. There is no sign in front of them that says, you know, like what you see there. They're not easily discernible if you were to try to, you know, hover the Google Maps over Ashburn, Virginia. You know, figuring out which of those buildings is ours is going to be pretty challenging. Security by obscurity is usually not a good idea, but when it comes to physical security, security by obscurity is actually a highly effective way of keeping the bad guys away. Now, speaking of bad guys versus good guys, who's allowed to go into our operations facilities? We are very big believers in the notion of the principle of least privilege. I'll come back to that a couple times throughout the conversation today. But one of those is if you don't have a job duty to get into the physical facility, you can't get there even if you are an Amazon Web Services employee. So even though I am an AWS employee, and even though my specialty is security, privacy, compliance, and all of that, because I'm not an operator of the facility, I can't just phone someone up and say, I'd go like to take a tour of the data center, please. I'm not allowed, right? Only AWS employees who have a job function that requires them to go in are allowed to do that. And then when they do, they get a time-limited token that limits what they can do, where they can go. They can't just wander around everywhere. Multiple factors of authentication are required. We do background checks for all of the employees, and everything that they do is logged, probably on that ancient dot matrix printer right there. The ribbons are getting harder and harder to find for that thing, by the way. And then, just as part of our desire to be as transparent as possible, we have a dashboard so you can check to see what's going on in the physical locations, and you'll notice that there's tabs there for all of the different regions. And we lump North America together, the two, Virginia and California, into a single tab. Now, why multiple regions and why multiple availability zones in each region? Each region is a distinct entity, and to help you satisfy regulatory requirements, we will not move data from one region to another. That doesn't happen, right? If you put data in the EU region, it will stay in the EU region unless you decide to move it somewhere else. We will not move it. There's no procedure under which, under the covers, without your knowledge, will that data leave Europe and go to Singapore or to the United States. And if you do decide to move it, that just moves over the regular internet. There's no private links that we have between regions, so we keep them highly isolated. But within a region, depending on the service, we might make multiple copies of the data that you store, either within a single availability zone or across multiple availability zones. This is how you get that very high durability. And when you think about something like S3, S3 is one of those services where we will actually make multiple copies of your data in multiple availability zones as a feature of the service. You don't pay extra for that. It just happens. So we've measured a durability of 11 nines in Amazon S3. Amazon S3 has been around for about 4 years. There's 180 or so billion objects, and we haven't lost one yet. We built it to function this way on purpose. Somebody once asked on a security questionnaire if we do tape backups. No, we don't do tape backups because there are live copies of your data at all times. So no, we don't do tape backups. It's kind of interesting, the questionnaires that we get from people, because it's obvious they've just downloaded some questionnaire from Google somewhere, right, for some ASP from 10 years ago. The models do not apply in cloud that apply with traditional web hosting. So EBS, that's Elastic Block Store. This is a persistent block storage. It's like, it gathers up a bunch of disk space and you attach it to your instance. This would be your C, like your D drive on a Windows box, or another volume on a Linux instance. When you allocate an EBS volume and you store an object on that volume, again, we will make multiple copies of that. It happens under the covers as part of the feature, or it is a feature of the service. But because EBS volumes are associated with an instance, and an instance lives in only one AZ, your EBS volume is only in that AZ. So there's no multiple AZ replication for that. And then, of course, for the server itself, we call that ephemeral storage. Right? So the operating system itself, the hard drive that the volume the operating system is on, do not rely on that as a storage location that is permanent. Because if you terminate the instance, the data that was on that instance is irretrievable. So let's talk about what happens at the disk level. With EBS, so EBS is, the way we handle disk is distinct from the way we handle disk for everything else. The way we handle disk for EBS, when you say, give me a terabyte or a gigabyte or whatever, and you hit the go button, there's a delay between when you hit the go button and when the light turns green. That's because we're actually wiping those blocks or zeroing them all out. So you get fresh, clean disk that doesn't have any data on it. With everything else, so this is for ephemeral storage, this is for S3, this is for the disks that back SNS, SQS, all the other services. We have a virtualization layer that lives on top of the physical blocks. And what we do is, let's say, for example, that you've booted up an instance, it's got an ephemeral store, it's got 160 gigabytes of ephemeral storage. We go out and we find unused blocks. Doesn't mean that they're empty. It simply means that they're not allocated to a customer. We mark those blocks as belonging to you using a table. We call it a virtual to physical mapping table. And then we present that to you as a volume. Okay, here's 160 gigabytes. Now, the thing is, it isn't 160 gigabytes that have been set aside for your use, right? It's just a logical table in memory. If you try to read something, we're going to send a null because you haven't actually written anything to that block yet, right? And we know that you haven't written anything, so we give a null. The only thing you're going to be able to do is write. You have to write first, and then if you try to do a read, we'll give you back the contents of that block. So this is how we prevent data leakage from one customer to another while keeping the disks at maximum utilization. Because a wipe is actually an expensive function. So we don't do wipes. Instead, we rely on the virtual to physical mapping table. But we do the wipe for the EBS because that improves performance for EBS. Now, I sort of, only by accident, kind of discovered the technical method by which this works, because I was looking at a trouble ticket one day where a customer, they had their SQL server running on the C drive, the ephemeral drive of a Windows instance. And realized that was probably not a good idea, because if that is terminated and we delete that mapping table, there's no way for us to reassociate the blocks, right? I don't know whose blocks are whose at the physical level. If you walk into the data center and get past all the physical security and you yank a drive out of the frame, there's no context at all about whose physical blocks belong to whom. That's all handled in memory. So anyway, this customer realized that putting their SQL server on the C drive was not a good idea. So they kicked off a replication to an EBS volume and went home, because it would take a long time. It was it was a huge database. This guy's manager, sitting at home, decides to log into the management console, sees this extra instance and a replication, doesn't know what's going on, and instead of calling his engineer and saying, why is this happening, he just decides to hit the terminate button himself. Now, the trouble ticket actually says that customer calls and says that our console went haywire and started terminating instances on its own without him doing anything. And I'm like, well, let's just do a little bit of log correlation, and I can go look at the EC2 log, I can look at the ephemeral store log, and I can look at the console log, and I was actually able to correlate and say, no, at 7:35 p.m. from IP address, well, your house, the console button, the terminate button was pressed, right? So, difficult lesson that the customer learned, but it was useful for me to understand how this mapping table works, and so that's why I've added it to the presentation. I want to try to hammer home to you that if you need storage that is persistent, use EBS, right? That's the lesson to take from this. But disks do fail eventually, right? So there's this rumor that persists when a disk drive, when a physical disk fails, that we just chuck it into the trash. We don't do that. No, that's a bad idea. There's still customer data on the disk, right? So to ensure, again, that we limit the risk and exposure, in this case, we eliminate the risk of exposure by following the DoD and NIST procedures for physical destruction and degaussing of those drives. Right? We don't have a physical destruction machine in Singapore, so we use a degausser. The physical destruction machine is on order, it'll be there soon. But we do either of these procedures, right, to make sure that the disks themselves are just completely useless. Okay, so that's disk. Now let's move on to compute. Our host operating system is Red Hat. We use the Xen hypervisor. We make some modifications to Xen to do some further isolation between the hypervisor and the hardware. But the other thing that we do is it is in the hypervisor where we add this code for a thing called a security group. And I'll come back to what a security group does in a moment. I want you to think of it right now as a software firewall that lives outside of the host of the guest operating system. So by having this sort of division here, we've built the environment in such a way that we isolate the virtual machines from what the AWS operators can see. So the AWS employees can log into and manage the physical machines, right? So say, for example, that there's a patch that has to be installed from Red Hat. Well, what we'll do is we'll mark that physical machine as, we don't bring the physical machine down because we don't want to destroy the customer instances that are running on there. But we'll mark that machine as no new instances. Right? And so we'll wait until the virtual machines that are currently running on that box are all terminated. And then, we have an automated mechanism actually that goes out and pushes those patches. It isn't that somebody sits on the logs on the console and does that. So that's how we just have that kind of rolling update that's going. But if we do need to do some management at the physical level, that information is logged and it's bidirectionally authenticated from the operator's console. But we don't know what's going on in your VMs. You know what's going on in your VMs, right? We don't have a visibility into there. We don't know, we'll know what operating system that the VM is running because we have certain placement logic that minimizes our licensing costs from Microsoft to make sure that we put all Windows instances, on the same hardware, right? Because of the way Microsoft charges licensing. But other than that, we don't know what you're doing in VM. We don't know what applications you're running. We don't know what data that you're processing inside the VM. It's up to you to make sure you're following the license agreements with whatever that you're running, right? We're not policing you here at all. And that's intentional, right? We want you to know that if you're going to run an app or you're going to install some data in EC2, that data that is private, that belongs to you. We don't see the data. We don't make any derivative use of that data. We don't do any data mining. It belongs to you, not us. What matters to us is the integrity and safety of your data, not what your data is. Which actually brings up kind of an interesting notion when you think about it, right? We like to kind of talk about this idea of shared responsibility. So we take care of you from the concrete to the hypervisor, which means the work that you have to do if you build your own data center is actually, you don't do that anymore, right? We take it up for you. But we don't do everything. You still need to make sure that your instances are secure. You've got to keep those up to date. You have to make sure that you're writing good, secure applications and that you're doing the proper things with data stewardship, like encryption where necessary. And I'll come back and talk about encryption a little bit later, too, right? But we're not going to look at your apps and try to find SQL injection vulnerabilities in your apps, right? Although you could hire someone to do that if you like. So by building the infrastructure the way we have, a lot of the common things that bad guys might try to do to attack, whether they're coming from the outside or attempting to use EC2 to launch attacks, we actually just block that stuff, right? So there's a fair amount of logic that's in the switches at the top of our racks that blocks the traditional methods by which people try to do denial of service attacks. We prohibit instance-to-instance communication from the backside. It's got to go out over the public facing. Any communication leaves the virtual NIC, goes out the physical NIC, goes to the switch at the top of the rack. We look and we say, okay, is this customer allowed to talk to somebody else or not? And either direct the traffic or drop the traffic. If you try to generate datagrams with spoofed source addresses, we're simply going to throw those on the floor. We're not even going to give you a reset back. If you try to put the NIC in promiscuous mode to do packet sniffing, it simply won't work. You're not going to get an error message, but if you start up the sniffer, you're only going to see traffic that's coming into or going out of your own virtual machine. You won't be able to see what's in the physical NIC. And port scanning is prohibited by our acceptable use policy, and if we detect that you're doing port scanning, we're going to call you up and we're going to say you better stop, and if you don't stop, we're going to turn off your instances, just because that's, that causes poor performance for other people who might be sharing the resources that you're on. And so that's just a prohibited behavior. Now, so we've talked about networking a little bit. The network at AWS is a flat network. It isn't a tiered network. So if you've got an application, or if you're accustomed to building multi-tier architectures, how are you going to do that in something like this, where you don't have VLANs, you don't have subnets, you don't have router apples where you can direct traffic? That's what security groups are for. So remember, you saw in the earlier picture that there was this thing called a security group that lives in the hypervisor. That's custom code that we've written, and we've worked internally and externally. We do regular penetration tests against that code to make sure that it doesn't have vulnerabilities in it. But think of it as a software firewall. You are required to define this. You cannot start an instance without associating it with a security group. The security group has a list of rules that defines the traffic that is permitted to come into an instance. It's a source port, source protocol, destination port, destination protocol, and source IP address. So if you conceptually think about how a 3-tier architecture looks, you're going to allow web traffic from the internet. You might allow management traffic from your corp net. But the application tier, even though these machines have public IP addresses, you don't want to expose the application tier to the internet. So you're going to write your rules a little bit differently. Again, you might allow management traffic from the corp net, but you can construct the rule so that inbound connections are permitted only from the servers in the web tier, not from everybody on the internet. Then you do the same thing for your database tier, right? So this is how it would look if you did it at the console. You can see that there are 3 rules there. One rule is, my corp net, right? RDP from 23.45/16. The other 2 rules allow inbound traffic from the internet. That's what 000 means. HTTP, HTTPS, perfect for a web server, right? There you go. This is what the application security group looks like. Now you'll note, again, down here is the rule for RDP. But then instead of specifying the IP addresses of my web servers, I just put the name of the web server security group there. The benefit is, if my web server farm auto-scales up because I've suddenly become really, really popular, I don't have to go in here and add a bunch of rules so that all those new web servers can talk to the application tier, right? Or if servers stop and restart and they get new IP addresses, again, I'd have to go change those rules, but instead, by simply referencing the name of the security group, I can allow the web tier to scale up and down without having to change my firewall rules. But look at those rules for a minute. I went to the console and I typed the name of WebSG and I hit the save button, and it actually created 3 rules for me that allows all ICMP, all TCP, and all UDP from the web group. Our old APIs, we're constantly updating and fine-tuning the APIs. The old APIs, when you used a security group as a traffic origin, defaulted to this behavior. The console still shows this, right? And again, you can see it for the database security group as well. The current version of the API actually is a little bit more intelligent than the console at the moment. And if you use like the command line utilities, right, or if you're scripting this, instead of allowing the application security group to listen for all traffic on all ports and protocols from the web tier, you can limit it to the particular protocol necessary and the particular ports necessary that the applications are listening on. So while you can do most of the console now, please define your security groups with this. We will fix this in the console so that the console doesn't build all 3 of those rules, right? It just builds the single rule that you specify here. I don't know what the timeline is for that. I do know it's a high priority for the console team, though. Now, let's think about something for a minute. When you look at these rules, what is open to the internet? The web servers, right? Now, let's say that you built up a Windows box and you left everything set at the default, and is an IIS box listening on anything more than 80 and 443? Sure it is. It's listening on all kinds of stuff, right? But you don't have to worry about that, since you don't have a security group rule for file sharing. If someone attempts to do a Samba connection or something like that to your IIS server, the security group will block that. So this kind of helps protect you, right? This is your foundational level of protection. But no one really attacks web servers that way anymore. People attack web servers on the open ports with URLs that are really, really long, trying to find buffer overflows, or malformed HTML, these kinds of things, right? This is how people break web servers. Or they try to circumvent your security by conducting some kind of SQL injection attack and get through your app and into the database, right? So what could you do if you have this model to help protect your web servers and your applications from attack traffic that looks a lot like legitimate traffic? Well, I recommend that you actually implement an inspection tier. Okay? So here's my first sort of, I've been talking about what we do at AWS, so here's a suggestion for what you can do in this notion of shared responsibility to add a little bit more protection on top of that. And instead of exposing the web servers to the internet, you can see that my rules now say you, web server, are only allowed to accept traffic from servers that are in another group called inspection security group. And in inspection security group, I have a few virtual machines, a few VMs, that I am running my favorite web application firewall, or my favorite intrusion detection or intrusion prevention system, like from WebRoot or Snort or something like that, right? That's what you expose to the internet. And then you get a higher degree of protection of your web servers, your applications, and your database by adding a tier that understands how modern attacks are constructed and is able to respond, right? If you are actually exposing a SharePoint server or a file server, you're going to want to put an antivirus program in your inspection tier, right, at least. So this is a really good idea, and I'm actually trying to work through how I would maybe write a blog post about this. If you are a seller of security products, I would encourage you to consider, virtualizing those and putting them in our Amazon Machine Image catalog and making a little bit of money off that. My favorite feature in AWS is this one. It's called Virtual Private Cloud. This allows you to carve out a portion of EC2, and instead of making that available to the internet, it's available only to your CorpNet. It kind of works this way. You're going to begin by issuing a series of APIs, and we're actually going to add this to the console pretty soon. Actually, it might already be there now, I'm not quite sure. Where you're going to send some commands to a router on our network. And that router initiates an IPsec tonal mode security association, which has a few certain technical requirements. The most challenging one is BGP. Between the router on our side and a router on your network, right? We've tested this with gear from Cisco and Juniper, and if you actually are using a Cisco or Juniper router on your network, at the end of this process, we will give you an XML file it's a script, basically, that you run on the router to configure the customer side of that. If you're using something other than Cisco or Juniper gear, we'll just give you a file that that says, here's what your network admin has to configure. The BGP is the challenging aspect of this here. Not everybody's able to get that done easily. But once you get this set up then, you can issue commands to the subnets in your VPC. One of the things that's unique about this is we don't assign IP addresses to those instances. You do. So it's your IP address range, not ours. Furthermore, these instances do not have internet access. They can only route out to your CorpNet. Now, just kind of a little sort of lesson learned thing here. I used to build VPNs quite a lot, and one of the things I always forget to do was program the return route. You know, so I get everything set up, and I'm trying to ping that thing on the remote side. I've got sniffers running, and I can see that the requests are getting out there, and the replies are being generated, but I'm not seeing the replies, and it's because I forgot to write the return route on my own router. Now, just a small little lesson, right? Make sure you get the return route configured correctly here. You know, the beauty is here, this is an extension of your data center into ours. So the physical resources, the virtual machines, are all sitting in our data center, but as far as the routing, as far as the topology is concerned, your network sees it as a part of its network, right? Not as a part of ours. Now, some things to note. VPC right now, you can get on-demand and reserved instances. It's only in one availability zone in Virginia, one availability zone in Europe. We will be expanding that to multiple availability zones, so you get that high redundancy within VPC like you get in public EC2. A couple other things that we're doing that I'll kind of highlight in this list of planned improvements. One of them is the notion of subnet ACLs. So, for example, you'll be able to say that, okay, this subnet here is permitted to make outbound connections directly to the internet, instead of having to go out this way. Why would you do that? Well, you know, if you got a bunch of Windows boxes and they need to go up and go talk to Windows Update, you can minimize your bandwidth costs, right, by allowing those things to go directly out to Windows Update. Or, for example, you could, within VPC, build a multi-tier service. Right? You could say that this subnet is allowed to have inbound connections, but these other subnets are not. So you'll be able to kind of do inside VPC what you were doing with security groups that I showed you earlier, all on the public internet, but this would be considered private, and you're exposing only a certain portion of your VPC to the public. But the other thing that's interesting is the fact that very soon you will be able to have multiple customer-side routers pointing into a single VPC. I love this feature because this is what is going to allow you to not have any more corporate IT. Did he say? Think about this. Instead of having that data center that's sucking up power and is only 20% utilized someplace that you have to keep at 65 degrees all the time, you're just going to put all that stuff inside a VPC or two, and at all of your regional offices around the state, around the country, around the world, whatever, you're going to put a small little Juniper device or a Cisco gateway, and you're going to configure that thing to talk to your VPC. We're going to eliminate the requirement for BGP, so you'll be able to use, instead of, you could use IPsec if you wanted to. I would still recommend you do that because it's the most efficient. Or you could do an SSL VPN if you wanted to. That's easy because it's firewall friendly, as they say. But you're going to encounter a problem called TCP over TCP meltdown if you use an SSL VPN. If you don't know what that is, go Google that. It's a really interesting problem. Trying to take a TCP datagram and put it inside another TCP datagram, you're making TCP behave in a way it was not designed, and you're going to have a really serious performance hit. But if you want to do that, you'll be able to do that. Now, S3, the storage service, there are two ways in which you can express security policies. The old way is what we call bucket ACLs or object ACLs, access control lists. And there is an interesting thing here, just keep in mind. Unlike a traditional operating system where you put an access control list on a folder or on a subdirectory, objects that you put in there inherit, that doesn't happen in S3 ACLs. ACLs on buckets do not inherit to the objects that you put in them, right? You need to maintain those ACLs separately. A few other things, just since I'm talking about S3. When we've initially built S3, the kind of thinking going through the minds of the engineers, it's key value storage, right? And so a lot of the documentation for S3, when you see the word key, Don't assume that means it's an encryption key. There's no encryption by default in S3, all right? The word key means the name of the object. It's a file name, but for some reason the documentation refers to it as key. S3 also offers versioning support. If you enable versioning support, then every time you store an object in S3, instead of overwriting the prior one, if it was there, it just creates a new version. So essentially you can maintain a history of everything you've ever done. Be careful. This could have possible legal implications if you get served a discovery notice because you've done something that somebody wants to sue you for. Just remember that. Because remember, once you get served that discovery notice, you're not allowed to delete anything anymore. That's why retention policies, I believe, are really, really important, especially for email. All right? Yeah.
So you don't have something like smart version, right? Like it just keeps it different. You keep a physical extra copy and you will be charged for that.
Well, if you do turn on versioning support, it's going to cost you, right?
Or double, or like if I put a new version of it.
We keep if you turn on versioning support, and you've got, you have, bob.txt up there, right? And now you turn on versioning support, and you upload a new copy of bob.txt. Well, we're going to mark that other one as old, and then a new one. But you will pay for the storage of both of those.
No, but is it going to be like 2x, or it's going to be x plus just the delta changes?
No, it's not delta changes. We keep full copies. I see, right? Yeah, it's not a diff. It's full copies. Yep. And the reason why we do that is, let's say you've got 5, okay? If all we did was keep diffs, and you want number 3, it's really hard to go back and get number 3 with just diffs. So that's why we keep full copies. However, there's a different way you can express access controls other than the traditional ACL method, and that's through something called bucket policies. So you got to know your JSON here, right? There's no friendly UI for this at the moment. It's just a JSON expression that gives you a choice of 25 operations that apply to buckets, folders within buckets, and files. And you get a lot more granularity. So using bucket policies, you can use a single policy that applies to multiple objects. You can have custom conditions and request attributes there. You can combine ACLs and bucket policies if you want. Somebody asked me yesterday, and I don't know the answer to this question, so I'm going to try to find out. It's probably documented, I just haven't read it. Which one overrides? If you have an ACL that says no access, but a bucket policy grants somebody access, I actually don't know off the top of my head which one actually takes precedence. So I'm going to have to try to find that out. Since I mentioned the word key earlier, I'd like to take a moment and talk about encryption, just because this topic always comes up when I'm in one-on-one conversations with customers. Do you have to encrypt everything you store with AWS? No. Remember the technical and procedural controls we have in place to limit exposure of your data to our operators. Should you encrypt some stuff? Probably, if you are dealing with regulatory regimes that require that you do that. For example, HIPAA. You can be HIPAA compliant on AWS if you encrypt the PII and the health information of your customers, right? That is entirely possible. HIPAA requires that you do that. So you can do that. We do not place any restrictions on what encryption tools that you want to use. So if you're using Windows, use BitLocker, use EFS. Roll your own with DPAPI. Don't roll your own algorithms, but you can at least write your own modules, right? You can use TrueCrypt. And whatever you want, you're free to choose. Now, it does mean that you have to manage your keys, right? And key management is a non-trivial task, but people are doing it. People have done it successfully. If you lose the key, your data is gone forever, right? So that's why you got to take kind of good care of those. The most important thing I want you to realize, though, is that there's a lot of people out there who are going to try to sell you bad encryption. Now, we all love shiny new gadgets, right? Whenever there's a new phone that comes out, we all rush to the store and buy the new phone, or the new laptop, or whatever. Shininess and newness is good, not for cryptography. In cryptography, age is good, right? Now, I don't mean algorithms from 1850 that are just obfuscation. I mean good algorithms that have withstood the test of time where people have attempted to try to break these algorithms and have failed. AES is a good example of an algorithm that has withstood the test of time. Triple DES is still pretty decent too, even though it's slow. Now, AES, you can choose 128 or 256. 128 is the perfect trade-off between performance and durability of the protection. The universe is about 13.7 billion years old. Best estimates are to crack AES 128 by a brute force method is going to take about 4 billion years. If your secrets need to be safe longer than 4 billion years, then I'd be really interested in talking to you about what your business is. You do not need to use AES 256. It's twice as slow. But there are some flaws, actually, in the key scheduling algorithm for AES 256. Bruce Schneier talked about this a year or so ago in a blog post, and it is roughly equivalent to AES 192, if such a beast existed. But it's still really, really slow. So AES 128 is fine. Just avoid people who are trying to sell you some product where they won't tell you what the algorithm is, right? Or they make these claims like million-bit keys and stuff like this. This is garbage. I call it encryption. Stay away from it. This is a new feature, and I think this is one of these things that's just going to completely change the way people relate to AWS and use it. In the past, you've had one AWS account that can do everything, right? We've added a fairly sophisticated identity and access management feature on top of that. So you have a parent account, and you'll note that he's the only guy who dresses up now. And within the parent account, you define security principles. A security principle can be a person attending a conference, apparently, a group of people. A security principle can be an application, or it can be a service. Now, what can you do with security principles? Well, you can assign credentials to principles. Now, that arrow could point to any of those. I just draw it to the person for simplification of the diagram. You can grant permissions to security principles. Those permissions can include conditions. Now, think about what you can do here, right? So now you could say that users in this group are allowed to start application instances only. Users in this group are allowed to log in and modify my web servers. Users in this group are the only ones who are permitted to modify security groups. So you can now start to implement a separation of roles and separation of duties with the IAM that you never could do before with AWS. There's a fair amount of learning to do here. Identity and access management is hard. There's a lot you have to learn, a lot you got to get familiar with. So there's a fair amount of documentation that we've published. IAM is currently in what we call preview beta, so anybody can sign up for it, but it isn't finished yet. However, this is sort of the way we do things, right? I tell you, working for a company that releases a new product every 7 days is kind of a challenge. But what we wanted to do was throw something out there and start to get customer feedback so we can figure out what's the best direction to take this. So IAM works with the list of products that you see on the slide there. Today, it's only configurable via API. So you use an API to define your roles, to define your users and groups. It's all API calls. We are going to add console support for this in the near future. You will be able to use the console to define your users, and then you will be able to have your child users log in to the console. So that's the order in which that's going to happen. And by the way, IAM is now a fundamental feature of AWS. It isn't something that you pay for extra. One important thing that I encourage all of you to do is start using multi-factor authentication tokens for your AWS accounts. And I mean not only for the parent account, but also for all of the child accounts as well. Because if you think about what an AWS account can do, right, it can manipulate resources. Improperly used, a compromised AWS account could cost you money. one of your own employees with an AMS account could also use that account to order items from Amazon.com. We're working to fix that too. There will be some separation there, right? And one of the interesting things you'll be able to define with child accounts is you're not allowed to use that account to go to the retail site. Okay. Nevertheless, I would strongly encourage that you use MFA tokens for every account, so that even when someone in the developer group wants to log into the console to start a new instance, they have to have that MFA token. One other thing I want you to do, and let's go back and look at this for a minute. Once you get all this configured, one of the things you need to do is set up a group that you're going to label administrators or root users or something, whatever language is comfortable for you, right? And you're going to put your administrators in that group. And then the MFA token associated with the parent account, I want you to take that thing and drill a hole in it so that it is not usable. You have essentially rendered the parent account useless, because remember, the parent account can do everything, right? So to minimize risk and to maximize the dispersion of whatever risk remains, by having separate administrator groups, separate administrative roles, and then rendering the parent account useless, you've accomplished a very, very important task, and you've eliminated the situation under which a single compromised account could completely destroy all of the work that you've done. People don't always like it when I say drill a hole in the token, but I mean, if a token is required to log into the parent account and the token is malfunctioning, you ain't getting in. So that's my solution to that. No security presentation is complete without talking about compliancy. Compliancy and accreditations are not necessarily the same thing. As I mentioned earlier, HIPAA compliance is possible. It's largely dependent on what you're doing with the applications and data. I don't know if you're aware of this or not, but with the American Recovery and Reinvestment Act of last year, there was a subsection of that called the High-Tech Act that strengthened requirements in HIPAA. And it more stringently defined what is called a covered entity. So I sat down with some lawyers, and we actually had to hire some outside counsel. Amazon Web Services is not considered a covered entity under HIPAA. Even though you might be storing health information in an EBS volume or on an S3 bucket, because we are not programmatically accessing that data, we're not considered a covered entity. But you still do need to encrypt it to be HIPAA compliant, so that's possible. We've gone through, we are now just finishing our third round of SAS 70 audit, and I now need to actually change this slide. Our ISO 27001 certification is complete. We will be making an announcement next week. We're just waiting for it to go through final legal review right now. I already have the web pages propped up. I just got to hit the publish button when the lawyer says I'm allowed to. We followed the 27002 control matrix, and we added more. We felt that there wasn't enough, so we decided to be a little bit more stringent than what you get with just 27002. And by completing that, we also have achieved the FISMA authority to operate at the moderate level. We do this because we want you to know that we take this stuff very seriously. And by achieving these accreditations and certifications, it helps kind of cement in your mind this notion of the shared responsibility, and it introduces a new concept. You can be compliant by inclusion. So if you want to deploy an application that is, FISMA moderate, and you want to do that all by yourself in your own data center, you have to worry about everything, right? But if you do it on AWS, we are already taking care of the FISMA compliance, as I said earlier, from the concrete to the hypervisor. And we can give you a document to assert that. So all you need to do with your auditors is concern yourself with your VMs, your apps, and your data. And then you take our compliance document, incorporate that into yours, and you can be fully compliant by inclusion. And all of the compliance bodies understand this, except PCI. So we're trying to work with them to get them to understand what that means too. That's why you don't see that on this. Last couple of things I'd like to just sort of mention briefly here in closing. We have a lot of customers who ask about two things. One is, hey, I think I found a vulnerability in AWS. Who do I call? Well, there never used to be a place for that, and we've changed that. We now have a dedicated mailbox, aws-security@amazon.com, that is monitored 24 hours by people who carry pagers. I also see it, so I get to see everything that comes in there, but fortunately I'm not the on-call. But we do have people on-call 24 hours. So if you think that you've found a security vulnerability somewhere, and now that we have our own version of Linux, you know, the Amazon Linux, this is going to become even more important. Work with us, please. Responsible disclosure is something that we are firm believers in. And we will do everything we can to get that vulnerability repaired, publish a security bulletin. I usually end up writing those, and we'll get that out there to protect everybody. The other thing that people want to do is they want to be able to conduct penetration tests against their own environment, which is a very, very valid step in any security verification process. Our terms of service used to prohibit that. We've changed that. You are now permitted to conduct penetration tests against your own instances. There are a few conditions, though. You are not allowed to do a denial of service attack under any circumstance, right? That's not permitted. You are not allowed to do something that would spin up our internal incident response team, because we need those guys to be available when there's a real attack, not a simulated attack. Other than that, you can use whatever tool you want to do your penetration tests. If the tool does denial of service attacks as a part of its sequence, you need to disable that function in the tool. And there's one other restriction. Because micros and smalls, you know, those are micros and smalls are placed on machines that are highly utilized. And before we released this policy, we actually did our own profiling of what typical penetration tests might do. And it turns out that even simple penetration tests, like, you know, simple vulnerability scanning, can affect the performance of other people sharing the resource where we locate smalls and micros. So we don't allow tests on smalls and micros. If you're using smalls in production, but you need to do a penetration test, just start up a copy of your production environment on some mediums, do your tests, and then turn that off, right? Those are the only restrictions. If you want to hire a third party to do your vulnerability scanning, that is permitted. You can do that. And the Security Center is actually where you would go to learn how to do this. So you can see that we're starting to break this out into sections now. So we've got, you know, an updated list of security bulletins. There is an RSS feed for that. Please add that to your RSS reader. Here are the two policies for vulnerability reporting and penetration testing. The penetration test, again, that goes to the same email box. One of the things we do before we grant you permission is we verify that you are the owner of the resources you claim to be. And this is, as people say, this is to protect you, right? We want to make sure that it isn't somebody else attempting to try to attack you through a penetration test. So we verify that you are who you are and that the instances are yours, and then we grant you permission. Once you're finished, tell us you're done, and that's it. And that's pretty much all I have to say. Any questions, comments? What do you think? Does this seem reasonable? Are we doing the right things? Does it give you a better feeling? Yeah.